Let's look at another one. Now we are given two side lengths only. We are given two side lengths. We are not given any angle. So let's sketch this first. So sketch will look like this. Okay, B will be the right angle. We are told that. A and C doesn't matter where you put. Opposite of A is small a, so this is 325 kilometers. Opposite of angle C will be small c, so this is 240 kilometers. Okay, and we need to solve for angle A. So we need to solve for this, and side length B. This is what we need to solve. Now, we can solve for B first if we like. We can use Pythagorean theorem. We can say A square plus C square equals B square here. So in our case, 325 square plus 240 square equals B square. So 325 square plus 240 square, and square root that will give us B. Okay, so add those two numbers and square root them will give us B to be roughly 404.01, and this will be in kilometers. Now to find angle A here, we can use opposite over adjacent. This is our opposite, this is our adjacent. So the one which connects opposite and adjacent is tan. So I will say tan angle A equals opposite over adjacent, which in our case is 325 divided by 240. So if we want angle A alone, we use the inverse function. So angle A equals tan inverse bracket 325 divided by 240. We get then angle A equals, so whenever we want to find angle, we use inverse function. So angle A equals tan inverse bracket 325 divided by 240. We get 53.55 degrees. Now to find angle C, now I can use 180 subtract 90 subtract 53.55, or I can use tan theta again, but now from angle C's perspective, 240 will be opposite, 325 will be adjacent. So I will say here tan angle C equals opposite over adjacent, which in our case then here is 240 divided by 325. So we will then say angle C equals tan inverse 240 divided by 325, which will give us then angle C equals tan inverse bracket 240 divided by 325. We will get 36.44 degrees. Now if we were to add them, add these two here, 53.55 and 36.44, we will get 36 yes, this one. Now if you were to add them, you will see that it will be 89.99. It is off by 0.01. Reason being, when we do this one, we get 53.5555. So instead of 53.55 here, I should use 53.56 here. So now when we add them, we will get what we want. Okay, let's see few more. Let's say if we have this, we are given angle C to be this angle, and we already know angle B is 90 degrees. So if we were to sketch a right angle triangle, okay, let's label this A, B and C. Angle C here is given to us to be 64.3 degrees. Angle A is unknown. Side length B is 6.5 meters. A is unknown, C is unknown. Because we are given one angle, we can quickly find angle A to be 90 subtract 64.3. So that will be basically 25.7 degrees. Now to find other two side lengths, we can use from angle C, because this is opposite and hypotenuse is given. The one which connects opposite and hypotenuse is sine. So we'll say sine theta equals O over A. In our case, sine 64.3 degrees equals opposite is C, and this should be O over H, actually my mistake. This should be opposite over hypotenuse. So C over hypotenuse is 6.5. So if you want C alone, we can multiply 6.5 here. we get then C equals 6.5 sine 64.3 degrees. So we punch this in calculator. 6.5 times sine 64.3 degrees, we get 5.86, and this will be 5.86 meters. Now to solve for A again, we can use adjacent, because from 64.3 A is the adjacent, over hypotenuse, and that will be cos. So we say cos 64.3 degree equals A over 6.5. So then A will be 6.5 times cos 64.3 degrees. We get A equals, we will get A equals 2.82. We will get A equals roughly 2.82 meters. Now if you notice, the opposite of right angle, the highest angle is the largest length, longest length. Similarly, opposite of the smallest angle, 25.7 degrees, should be the shortest length, 2.82. We cannot be sure what will be the number, but we can at least double check that opposite of the smallest angle should be shortest length, opposite of the right angle should be the longest length. Okay, let's look at one more. Now we are given small a and small b, so we are given side length of A and B, and we need to solve for this right angle triangle again. So we have angle ABC, we are not given any angle. Small length A we are given to be 3.9 centimeters, and small length B, the hypotenuse, 4.1 centimeter. C is also unknown. So because we are given two side length, maybe this time we can start with solving for side length. Using Pythagorean theorem, we can say B square equals A square plus C square here. So 4.1 square equals 3.9 square plus C square. So 4.1 square subtract 3.9 square equals C square. So C will be square root of the number we get. So in our case, 4.1 square minus 3.9 square, 4.1 square minus 3.9 square, which will give us 1.6. And then taking square root of that, we will get C equals 1.265, roughly 1.265. So we will say 1.2649, so 1.26 centimeters. Now to find angle, doesn't matter which one we solve first. Let's say we decided to solve for angle C first. Respect to angle C, we are given adjacent and hypotenuse. The one which connects adjacent and hypotenuse is cos. So we will say cos theta equals adjacent over hypotenuse. In our case, cos angle C equals 3.9 divided by 4.1. So angle C will be then cos inverse 3.9 divided by 4.1. In our calculators, we'll punch in cos inverse 3.9 divided by 4.1, giving us 17.969. So 17.97 degrees. Now if you wanted to solve for angle A, respect to angle A, this is opposite, this is hypotenuse. So we will use sine theta, because sine connects opposite and hypotenuse. So sine theta equals O over H. So in our case, sine angle A equals, opposite is 3.9, hypotenuse is 4.1. So then angle A will be sine inverse 3.9 divided by 4.1. Punch in calculator with the bracket. So we will say sine inverse bracket 3.9 divided by 4.1. We end up with 72.03. 72.03 degrees. Now to double check, if we add those two angles, they should add up to 90 degrees, and they do. So that means our solution seems correct.